This is the Thermalmaster P1. It is a USB-C thermal camera designed for your smartphone for everyday thermal use. What's incredibly interesting about this camera isn't the spec, it's the price, because this camera is available for as little as £100 right now. In fact, this is the cheapest camera that I have seen from Thermalmaster to date. Now, obviously, at this price point, it is not going to be the perfect camera for everything. And today I'm going to give you a complete overview of this camera, what it's capable of, what it isn't necessarily ideal of. But I'm also going to show you some results from the P3 that I also reviewed on this channel a little while ago that is ideal for things like board repair. And I'm going to put a link to my full review on the P3 in the description as well. Thermalmaster are running some discounts on these cameras right now, so there will also be links to them in the description as well. Thermalmaster did send me these cameras over to take a look at. However, they've not paid me to make this video. They've not seen this video before it's been published. And as always, my thoughts are entirely my own. So the P1 is a smartphone thermal camera. It has a USB-C connection on it, and it will plug into the bottom of either an Android or a USB-C compatible iOS smartphone and give you a thermal image. The P1 is one of the cheaper models that Thermalmaster make. As I've said, at the moment, this is currently on sale for $129, but its normal price is just $199, which is incredible when you look at it. Now, when you get the camera, it comes in this pretty straightforward plastic packaging. We have a cardboard outside box. You have the camera itself, which comes in this nice little case. Underneath, you will then find our little instruction book, quick start guide, your warranty, as well as a USB-C to USB-C extension cable. Opening the case, you will find the camera inside. It is a very similar shape and size to the other thermal cameras that we've seen from Thermalmaster before. The first thing to note is that it does have a fixed focus lens. This camera isn't really ideal for very detailed board repair. This is a general everyday thermal camera. That isn't to say you can't use it for board repair, but I will show you later on the kind of image that you can get from it. This, though, is ideal for everyday general thermal use. However, if you did need a thermal camera with a bit more capability, including a variable focus lens, Thermalmaster also make this, the P3. Now, I did a full review on this camera on the channel a little while ago. I'm going to put a link to this in the description. This camera is a higher specification than the P1. It is more expensive as a result of that. It's got a metal outside casing, higher thermal resolution, but more importantly, this camera also has a variable focus lens. That means not only can you use it for general thermal use, you can get up nice and close to things like PCBs, making this one ideal for board repair. That isn't to say, though, you can't use the P1, and I am going to do a bit of a demonstration between these two cameras later on, especially when it comes to looking at some boards. When it comes to the main specification on this, it has a Vox detector with a resolution of 160 × 120 pixels at 12 micrometer. However, it also uses Thermalmaster's Super IR resolution feature, which will enhance that to 320 × 240 pixels. Don't just take that 160 × 120 and think, oh, it's not going to be any good. Look at the footage for yourself, which I will show you later, because I have found these cameras incredibly handy and versatile, even though they are using those lower resolution detectors. It has a measurement range of -20 to 600 degrees C, a temperature thermal accuracy of ±2 C, and an NETD of less than 40 mK, and has a 2.2 millimeter focal length. The frame rate on this camera, the update rate, is 25 Hz, and it's designed to be used with the Thermalmaster apps, as I will show you in a minute. As I've said, it is designed to connect to Android or iOS smartphones using USB-C, but you can also connect it to PC as well and use their PC-based software. Externally, this camera is made of plastic. It does have these sort of sections around here that give it that rugged look. And then we've obviously got a metal USB-C port there. There isn't a great deal to show you externally, and it simply connects to your phone by plugging in to the bottom just like that. On your phone, it is designed to be used with the Thermalmaster app, and once connected, you can click on the camera and then you should see it appear. There we go. You can now see the thermal image on the display. Now, just to give you a bit of a walk around of the app, on the left hand side, you have the main controls, and then on the right, we've got some of the additional functionality. For instance, X3 up here, this is the super IR resolution clarity mode. This is what enhances the image from the base thermal resolution of the camera. So on this one, 160 by 120, and they say this mode enhances the image up to 320 by 240. For instance, if I just turn that off, you can see the image has changed, and then if I turn it on, it definitely makes an improvement on the image. It is a really nice feature that Thermalmaster have on all of their cameras, and it really does help the camera punch above its weight with regards to the thermal resolution. Obviously, the hardware resolution isn't changing, but what you are doing is getting quite a nice enhancement on the camera, and you can see this even more if I zoom in. So for instance, if I just go there, turn it on and off, you can see that it does make a difference. If I then zoom and adjust the camera to look at the camera above and then turn it on and off, you can see that it does make quite a difference. Next to this, we then have our temperature measurement range. We have -20 to +150, 150 to 450, or auto. You've then got your shutter button down here, which is our calibration for the current temperature range we're looking at. And then we've got our options down here with our zoom being shown in the middle. Zoom is simply done by squeezing in and out on the screen. This is a digital zoom, not an optical zoom, so that's obviously going to go down in resolution as you zoom in. Down here then, we've got our features. So this little temperature one up here is we have our measurement options. And here we have things like point, so I can tap there and that will now measure the temperature at that point there. We've got line, so we can draw a line down the screen and it's going to measure it at different points on the line. We can draw a square, we can do a circle, or we can turn them on and off just like that, and then we can delete them all down there. Next, we have our color palette options. Now, this is the different palettes that are available on the camera. If we start at the top, we've got our white hot, black hot, iron red, red hot, rainbow, jungle, aura, city, low light, gold, lava, and medical. So depending on what you're doing will depend on the option you want to choose. So for instance there, I can choose that, turn on the enhancement. You can see the enhancement makes quite a difference on the medical one versus the others, and then you can see the difference as we scroll through. Down below this, we've got our capture options, so whether we want to record or capture a still. So I can capture a still to the phone like that, or I can hit record and that's going to start recording into the app on what we're seeing there as well. We've then got our picture-in-picture option, so this allows you to use it with your onboard smart device's camera. So if I turn that on, you can see that has now appeared up there. Because they are not linked, they are looking at different things. But if you were looking at the same thing, you can use that picture-in-picture mode. You can then align it with what you're looking at off your camera to try and give you a real-world picture-in-picture view. And then finally below this, we've got our additional settings such as our brightness, contrast, scale options, mirror options, as well as our rotate options. So depending on which way round you've got the camera connected will depend on where you want to set the rotation. Alongside recording video on these cameras, you can also capture still images, and those images also have the thermal data embedded into them. The nice thing about this is that you can actually go in after you've taken the image and measure the temperatures in different spots. So for instance, if I just point this down at my face and I'm going to go into here and I'm going to take a quick still image, I'm just going to get myself in the right position. We will take that there. Then I'm going to return to the gallery, We're going to go into portrait. We're going to go into there, select photo, select that image, and whilst it's on the side, you can see we have a few options along the bottom. We have edit, report, share, and delete. If we go into edit, allow, we can then actually interrogate the image from a thermal perspective. So for instance, we can click on it, select a point on the screen, and it will give us the temperature at that point. So I've selected point 1 and 2. So you can see point 1 on my nose is 30 degrees, point 2 is 22 degrees. We can then do all of the other options that we had earlier. So I can put a circle and it will do an average, a max, and a minimum. So again, just like in the live thermal image, you can also interrogate it after the fact. Also, you can change the color palettes. So we can scroll through the different color palettes that we had available when we actually captured the image. You can change these after the fact, again, allowing you to inspect the image later on. Alongside this, we also have the report function. This allows you to generate a report for the image that you've captured. So for instance, I can do that, and then you can export that report and then import that into other software, allowing you again to build up a picture based on the thermal images that you're capturing. Alongside your phone, you can also use these thermal cameras on your PC, and Thermalmaster have a dedicated app for that as well. This app has many of the same features that you get on the smartphone. However, it doesn't have every feature, including the enhancement, and as a result of that, you may find the image quality you get on the PC is not as good as you get on the phone. This is partly to do with the resolution of your screen on the PC, but also the different enhancement capability on the PC app versus the smartphone app. You can also still do all of the image analysis in the PC app like you can on the phone. So for instance, if you've taken a still like I have here, we can change the color palettes. We can also set temperature measurement points, reading the temperature in different positions, again, allowing for thermal analysis of the JPEGs captured via the camera. As I've mentioned, this camera is ideal for general everyday thermal use. Here we are looking at my 3D printer. This is my Bambu Lab P2S. The AMSs are in drying mode, so you can see the HT down there with a nice hot top end. Moving over to taking a look at some air source heating systems. Here we're looking at the outside of the unit. You can see there's some heat around the external chassis. Then we've got the lagged pipes going up with the sun has been warming that lag in on the outside. And we'll then move over to looking at the internal tank, showing you the temperatures on the pipework. So again, here you can see the tank itself is well insulated, but you've got areas where you can see the hot spots. These are the valves that mount directly to the tanks, as well as the lagged pipework. You can see the gaps in the lag in there. I'm going to do the zoom in a minute just to show you what this is like. So there you're looking at one of the fittings on the side. This is that digital zoom. So it's not optical. It's going to reduce the resolution, but it does allow you to get in and have a closer look. This is the heat bed on my H2D 3D printer. This just gives you an idea of that heating element. It's a mains heating element, and it shows you that heating up from complete cold. And then if we come back and take a look here, you can see it once the temperature is settled. There is a little bit of variance in it, but it isn't dramatic. It's this kind of general thermal imaging this camera is ideal for, with its fixed focus lens, larger items, electrical boxes, consumer units, wiring, larger electronic devices, anything where you want to be able to get a thermal image in a wider field of view. When it comes to larger objects, this is where this camera does well. Here, you're looking at the wheel and the brake disc on my car. Moving out into the field, I was trying to see here how it would pick people up at a distance, and it does struggle with this, but you can absolutely use it to look at property. So again, you'd want to look at areas where there is heat loss, things like that. But the resolution is always going to be a factor on this, but you can see it can be used in these scenarios. Here, just looking at the outside of this building, you can see the hot air duct system at the back, as well as the doors. And just like with people, it does struggle at long range with animals, but at short range, it is absolutely fine. And you can even see the result of his paw prints on the floor as he walks away. When it comes to looking at electronics, the P1 is absolutely capable of giving you an overview of what is going on, but what it's not ideal for is getting in up and close on PCBs looking at specific components. If you want to do work like that, you want to consider this instead. This is the P3 from Thermalmaster. I actually made a review on this camera a little while ago. This camera is fantastic for general thermal use, but also board repair, and that is because this camera has a variable focus lens, whereas the P1 has a fixed focus lens. Both of these cameras do actually have a similar thermal resolution, but the advantage to the P3 is that you have the ability to adjust the focus, making it ideal for everything I've shown you up until this point, but also detailed board repair as well. I'm going to do a comparison next between these two to show you the difference. Taking a look at this little Cadex drone with the P1 first, here you can see the motors are quite hot because it's been running. The electronics inside are quite hot as well. If I go into the motor, you can start to see where the focus becomes a problem, because whilst you can get in and look, you don't have the detail that you'll have in the other camera. Flipping it over to the bottom where we have the heatsink for the VTX, again, looks fine, but when you start getting in close, you just lose that clarity. Hopping over to the P3, this here is set at the same focus, but what you will see is that we have the ability to focus the camera in on that motor. So when we flip it back over, we'll go in and look close, and whilst it does go out of focus, we can then adjust the lens and start bringing it right back into focus, again giving you a lot more detail. Looking at this PCB with the P1, it's the same situation again. When we get in close, you then lose the ability to see those individual components, although you could still use this to identify hotspots. It's just you're not able to see the individual details. We can see there's a hot component there. On this side of the board, you can see that there's another hot one down there. So you absolutely could use it, but what it doesn't do is give you the clarity of this, the P3. So moving in closer, we'll again see that focus shift, but then we can adjust it. What you'll probably have noticed is that the P1 has a wider focus range, but the P3 allows you to focus in a lot more detail. And now we can go in even closer, adjust the focus to look at that component. And now we can even see the individual pins on the STM32 there. Looking around the board, you can see the pads, the button, everything in a lot more detail than you can on the P1. Looking at that component on the back of the board, but now we can go in and even see the legs off it, seeing exactly what's around it as well on the PCB. Okay, so that is the P1. Now, as I've said several times, if you want something that is going to get you a lot more capability with regards to resolution, but also variable focus lens, you want to check out that P3. Review in the description, a fantastic camera. But if you're looking for an everyday thermal camera, the P1 is phenomenal value. These tools are so handy to have around. I love these thermal cameras because they're quick, easy to use, they do a good job, and everyone can afford to have one of these in their toolbox these days, and they are just incredibly useful. Gone are the days are thermal cameras, thousands of pounds, and you can still spend thousands of pounds, but general thermal sensors have become so cheap now. For less than $150 on sale, you can get this camera, and for everyday general use, it's going to get the job done. Now, if you found this video interesting, as I've said, do check out the link to the P3 review. Also, there are links to either of these cameras in the description. I want to say a big thank you to Thermalmaster for sending it over for me to take a look at. And finally, I'd just like to say, if you'd like to support the channel, please do consider checking out the links to my Patreon, as well as buying me a coffee. It is only through the support of my Patreon so we're able to keep making content on this channel. And if you'd like to support us, please do consider checking it out. Anyway, that's it from me on this one. Stay safe. I will speak to you soon.